So welcome to this presentation by Christian Ronevik from University of Bergen. Christian will give us a short demonstration on how to access INTAROS catalog data from the IOS, the Integrated Arctic Observing System created by the INTAROS project. The INTAROS project is a Horizon 2020 project funded for 5 years, ending now in 2021. And the example or demonstration given here is how to access earthquake data in the Arctic region. And I will give the word to you, Christian, please.
Thank you. First of all, we will enter the official INTAROS website. To find INTAROS catalog data, we can go to the menu bar, click Data, and select the data catalog item. By doing so, we are redirected to the portal for the INTAROS data catalog, containing information about all datasets within key regions of the Arctic. From here, we can click the datasets link at the menu bar. We get a list of all available datasets collected by the INTAROS project. Since this is a demonstration about finding earthquake data, we can reduce the list by searching for earthquake. The list is now narrowed down to 3 items. To access earthquake data from the Arctic region, we can select the seismic catalog item. We then get some description of the catalog, who the contact person is, and when it was last updated. To find where the actual data is, we have to click the Explore button and then choose Go to Resource. We are then yet redirected into another page. However, this is a page by the institution that provides the data. The next redirection will provide you with the actual data. But to do so, we need to provide some parameters to define which kind of earthquake we are looking for. This page is a query builder page, presenting a form that will help you in providing the correct parameters. The parameters are defined by a European standard, which is the FDSN Bed Service Event Standard. This ensures that the request for data follow a community standard for querying earthquake data. All possible parameters are listed in this table. As you may have noticed, some of them are required while others are optional. Hence, the available parameters behind the INTAROS event service offers to filter data on all the required parameters, but also many of the optional ones, as demonstrated by the green highlighted fields. Now, let's have a look at the query builder form. Please be aware that this form may change in time and may include more parameters that are currently shown in this demonstration. The available parameters at your disposal are grouped into fields like catalog, time, region, and other parameters. All required parameters are marked by a star prior to the parameter name. By default, some of the input fields already have some values specified. This is to give you a workable example to start from. As of now, there are only one catalog available, namely the int2 catalog. Start and end time can be chosen by entering date and time values. The appearance of the input format is different depending on which web browser you are using. With Google Chrome, the value appears with the date and time separated by a white space. In, for example, Firefox, the text has a more raw text appearance. It is written in a way that it should be entered as a parameter in the generated URL. The appearance in Chrome is just for more user-friendly visualization, but is converted into the correct raw value upon sending the form. On some browsers, we can use the built-in datetime picker tool. In this case, we get a pop-up window where we can choose the date from a calendar and pick the time from a scrollable field. The data can be constrained to a geographical area by specifying minimum and maximum degree values for both latitude and longitude. The last section is the other parameters, which include a variety of different configuration options. Event type is the first listed, where you get a list of all event types included in the catalog. If the input is empty, simply meaning that you don't pick any type, the web service behind will ignore this parameter in search for data. This is true for all optional parameters. For this demonstration, we will search for events that are categorized as an earthquake. Let us keep the rest of the default parameters and execute the query. A new page appears, but at first sight, it seems like an error occurred. However, if we read the error message more carefully, it says that the document is empty. If we execute the same request for data in, for example, Firefox, we get a more meaningful response message, saying that no data matched our selection. It could possibly mean that there are no earthquake data within our selected time interval. Let us go back and select all event types and see if that alters our response. Now we are getting a page back structured by an XML format. This is the standardized European XML format for exchange of seismological data. The format is called QuakeML and the default version is 1.2. Let us investigate which other formats that are available. From the drop-down, we can see there are 4 different formats available. The XML and the text formats are defined by the FTSN web service standard. In addition, this particular instance offers to return the data in QuakeML version 2.0, which is the next generation of QuakeML, and also the Nordic format. Let us try out the text format. The data returned are presented in a tabular manner. In comparison with QuakeML, which is meant for computers to read, this text format is much simpler and prints one line for each event with some key properties. As we experienced with the filtering on event types, we can easily see here that the events listed are explosions or not reported events. We wanted initially to find earthquakes. Let us go back and widen our time interval and change event type to earthquake only. We will keep the output as text format since this is the most ideal in searching for larger intervals. If there are many events within a large dataset, the browser can easily get overloaded by rendering the extensive XML format. By default, there is a limit of 1,000 events for each query. This can be overridden if necessary. We can also change the order in which the events will be listed. Let us choose time ascending from the list of available order by parameters to get the oldest listed first. By executing the query, we get a longer list of earthquakes. We can further filter on magnitude and depth if needed, but I will let you try this out on your own. If you would like to use the data within other applications, you can simply copy the URL produced and do a request for this within your desired programming language. This is it for this demonstration of the INTAROS data portal. The tools within this portal has been developed in conjunction with the EPOS Norway project.